This lesson deals with supplemental problem 3.6. You can find this problem in the ECE302 ebook in the Chapter 3 Supplemental Problems on page 7. I'd like you to repeat supplemental problem 3.5, but now with beta F equal to 300. We have the same model we had on the previous page, it's just now that we're going to change the beta F value from 100 to 300. The base current calculation is the same because it didn't depend on beta F. It's still minus 0.7 plus 10 over 390K, or 23.8 microamps. But now the collector current is 300 times this number instead of 100. This is 7.14 milliamps. We calculate the emitter collector voltage. Same equation we had on page 6. It's 10 minus I sub C times 2.2K, but now I sub C is much bigger. It's 7.14 milliamps, and that gives me a negative 5.7 volts. I have a base current that's greater than or equal to 0. My emitter collector voltage is not greater than the emitter collector saturation voltage of 0.2. This is a contradiction. Since the emitter base junction is still forward biased, we can't be in cutoff, so let's guess saturation. Let's remove the active model that we had. Let's replace it with the one that's on page 18 of the Chapter 3 notes. We have a voltage source between the emitter and the base of VBE on, which is 0.7. We have a voltage source between the emitter and the collector, which is V sub EC sat, which was 0.2 volts. We have to show that the base current is greater than or equal to 0, the collector current is greater than or equal to 0, but also their ratio is less than or equal to beta F. Find the base current. Maybe the voltage across this resistor, so the rise in voltage would equal the drops around the loop, minus 0.7 plus 10, and then divided by 390K would be the base current, which is the same as it was before, 23.8 microamps, and that's greater than or equal to 0, so that checks. The collector current is the current in this resistor. Let's find the voltage across it. So rise in voltage equals the drops around the loop. The rise in voltage is equal to minus 0.2 plus 10 divided by 2.2K, and that's 4.45 milliamps, and that too is greater than or equal to 0. Let's form their ratio. The ratio of 4.45 milli to 23.8 micro is 187, and that's less than or equal to 300. Our assumption checks. We can solve for I and for V. I is still the same as I sub C, which we found to be 4.45 milliamps, but now the voltage here is going to be minus 0.2 plus 10, or 9.8. And this is supplemental problem 3.6.